Welcome to our seminar on how to wire your marine solar system. It is the intent of this seminar to provide you all the information you need to install and wire your solar system on your boat. My name is Tom Trimmer. I am the founder of Custom Marine Products, where we specialize in marine solar systems and battery systems. If you're just getting started with solar, here are some of our other videos that will help you learn about solar systems and battery systems. So if you're just getting started, these videos are available on our website at custommarineproducts.com under Support, Manuals, and Info. There are two wiring components to a marine solar system. The first is from the solar panels to the controller, and the second is from the controller to the batteries. So we're going to take these one step at a time. And in this seminar, we're going to first address wiring of solar panels to the solar controller. We're going to talk about marine solar wire and connectors, and then we're going to talk about actual wiring the panels to the controller. Then we're going to move on to wiring the solar controller to the battery bank. I'm going to provide you with some background in solar controllers and then some techniques for wiring the controller to the battery. We'll then talk about some troubleshooting techniques. And at the end of this presentation are wiring diagrams for different types of solar installations for you to refer to. So first, let's get started. We're going to look at all the components from the solar panel to the solar controller. We're going to address wire. We're going to address what are called MC4 connectors. And we're going to talk about putting an on-off switch in your system. So let's get started. We recommend using marine grade solar wire to connect your solar panels to the solar controller. Marine grade wire is tinned to prevent corrosion. We also recommend to use a high strand count wire of at least 50 strands. Our wire is 84 strand that we provide. The higher the strand count, the more flexible the wire is for running it through your boat. It won't fracture with boat vibration, and there's less resistance, so you have a lower voltage drop. Most solar wire is single conductor and with two layers, the first insulation layer and a second UV protective layer. We found that number 10 solar wire, which is about a 1/4 inch in diameter, is adequate for most marine installations. Here is a chart that's available on our website that shows you what gauge of wire you should use based on the length of the run and the number of amps going through the system. Quite often the number 10 or number 8 gauge is adequate for most of the solar systems installed on a boat. The length of the run, for example here, 11 feet, is the run from the solar panel to the controller and back, for example. Typically, we have found number 10 gauge wire to be generally adequate for most installations and provide a minimal voltage drop. Solar panels are often connected using MC4 connectors or plugs. Our CM Power solar panels come with a 3-foot pigtail for the positive and negative wire, with an MC4 male and MC4 female plug on the end of the pigtails. These pigtails then can be plugged into what we call an MC4 T-branch connector. So to wire in parallel, we would have the negative MC4 plugs plug into one T-branch and the positive wire from the solar panel into the other. Then from there, then you go to the controller mounted inside the boat. We provide coils of wire with MC4 plugs pre-mounted on them, so you don't have to have a special crimping tool to install them. Our coils are typically 50 or 60 feet in length, although we do custom lengths also. We put a male MC4 on one end and a female on the other. If you have a 60-foot coil, for example, you cut it in half, and now you have two 30-foot runs from the T-branch up on the bimini or arch or wherever, down to your solar controller. Any extra wire then can be used to run from the controller to the batteries. Now these MC4 connectors are waterproof. They seal around the solar wire, so you have a waterproof installation, and they make it easy for connecting and disconnecting your solar panels. The T-branch, the MC4 T-branch, allow you to wire multiple panels together and come down to the controller with just two wires. Now, a special crimping tool is used to install these connectors. And so here is a slide of the process should you need to install some of these MC4 connectors. A time you may need them is if you need to make some extension wires to go from the pigtails on the solar panel to the T-branch. So first you strip back the wire using a wire stripper as shown here. Secondly, you lay that wire into between two tabs on the metal portion of the MC4 plug. You use then a crimping tool, which is a special crimping tool with a die that rolls the tabs onto the wire. So it looks something like is shown in the picture here. Then the assembled wire and metal piece is inserted into the plastic plug, and it's inserted until you feel it click into place or lock into place. Then you tighten the nut on the back end of the connector, and that then tightens the bond around the solar wire for a waterproof connection. We're often asked what is the best way to get through the deck with the two solar wires, and there's a variety of glands and fittings to do this. Defender.com is a good source for such fittings. Of course, the simplest method is to drill a 1/4-inch hole in your deck for each wire, run the wire through, and secure it with a strong sealant. The other option is to use some of these fittings. There is a fitting that some people use that have the MC4 connectors on it so that you can plug and unplug the entire solar system at the deck level. Let's talk a little bit about our solar panels. The CM Power panels, both rigid and semi-flexible, as I mentioned, come with 3-foot pigtails with MC4 connectors installed. The junction box of these panels contain diodes so that if one panel is shaded, the other panels can perform and are not reduced in performance. We fill our junction boxes with an inert silicone so that the diodes and electronics cannot be exposed to corrosion and corrode. Some other considerations in our panels, they are very high output solar cells using sun power cells. Currently, the highest efficiency you can get is about 23.7%, which we use in our panels. The semi-flexible and semi-rigid solar panels are built using an ETFE laminate that is very rugged and it will not deteriorate from the UV. And our semi-rigid panels are designed that they can be walked on. So you have an entire variety of solar panels that come with wiring already on them. Well, there's two ways to wire your solar panel array. One in series, the other parallel. Let's talk about these. If we have, let's say, two panels that are 100 watts, 18 volts, rated 18 volts each, and 5.6 amps, if we wire them in series, our system will produce, we add the voltage. So a series system would be 36 volts and an output of the 5.6 amps. If we wire them in parallel, as shown here, by bringing the positive lines together and the negative lines together, we have an 18 volt system and we add the amperage. So we have roughly 11.1 amps coming from this system. Now, we recommend generally a parallel installation. And there's several reasons for this. Because our panels have built-in diodes, if one panel is shaded, so has lower performance, the diodes prevent the overall array from being hindered by that panel, and the other panels produce full output. On the other hand, if you're wired in series and one panel is shaded, the entire array will be reduced in performance to the level of the lowest producing panel. Also, as we saw in the prior diagram, the array wired in parallel has a lower voltage. And we want a lower voltage because our batteries require a lower voltage for charging. So while our controller will bring down that voltage, our lower voltage, higher amperage is preferable for our solar wiring. Now, all of our diagrams, you see a switch here, shown here, and the switch is used to turn your solar system on and off. The switch is recommended between the controller and the solar panels on the positive wire. Now, why would you need this? Well, primarily to prevent the alternator or the shore power charger from prematurely going into float mode. If you have an alternator running, it may see the voltage or state of charge of the battery plus the voltage coming in from solar and think that the battery system is in a higher charge state than it really is, and it may prematurely go into float mode. When it's in float mode, you're not getting the full power out of your alternator. So if you find that this happens, then you flip the switch and turn off your solar system so you get full output from your generator or your shore charger or your alternator. This doesn't occur on all boats and at all sun angles. So if you do find that you have an alternator that is shutting down prematurely, just turn off your solar system with this switch. The switch can be a simple bad handle switch. It can be a circuit breaker. It can be any sort of switch that will handle the voltage and amperage coming from your solar system. So let's start take a look now at our wiring from our solar controller to our battery bank. First, let's talk a little bit about what a controller does. The purpose of the controller is to optimize the power output of the solar array coming in and regulate the amount of power going to the battery. So, and prevent it from overcharging or overheating. The solar controller then can be looked at as kind of a negotiator. It looks at the solar panel and pulls the optimum power from the solar panel in the voltage amperage combination and converts that to the optimum solar or the optimum power desired by the battery or that the battery will take. So that's the purpose of the solar controller. There are two kinds of solar controllers. There's the PWM or pulse width modulated controller. They're less expensive and they're ideal for a smaller system. They pulse the power directly to the battery, and they're useful if the voltage of your solar system is close to the voltage of the battery. So if you have a solar system that's 18 to 20 volts, a PWM controller is very good. The MPPT, or maximum power point tracking controller, is excellent for higher voltage panels and larger arrays. And it optimizes the power from the solar array to the battery. So it brings down the voltage of coming from the solar panel and raises the amperage going into the battery. So if you have a small system under 200 watts, for example, the PWM technology is excellent. For larger systems and higher voltage systems, MPPT is the way to go. Look at some of the things we want to consider in wiring a solar controller to the battery bank. So unless there is a battery monitor, and we'll talk about battery monitors in a little bit, the negative wire from the controller would attach to the negative bus or the negative terminal of the battery. So if you have a bus on the boat to bring in multiple wires, negative wires, you can tie your negative from the controller to that bus or go directly to the battery. The positive line would go directly to the battery. The controllers accept bare wire, and so you literally strip off about 3/8 inch of insulation from the wire, insert it directly into the receiver, and tighten down a screw. So there's no plugs necessary in wiring to the controller. The ABYC standards say that you should have a fuse near the battery, and that fuse should be about 10 amps above what your maximum solar controller output is. So we highly recommend fusing the controller. Now, before you attach your solar wires to the controller and your battery to the controller, we always advise you to put a meter on the two wires to make sure that you have positive and negative correct, so that you insert the correct wires in the correct positions on the controller. Many controllers have additional ports for a load function. The load function is really used for lighting systems where you want to control the power on and power off of an integrated lighting system that is powered by solar. Quite frankly, I've never found a use for load in our applications in marine use, so ignore the load function on your controllers. You don't need any wires going in or out of them, and you don't need that function. There is an option on many controllers for a temperature sensor, which is a small cylinder that you can tape or attached to the side or top of the battery. If your solar system is heating the battery during charge to a point that it is not safe or healthy for the battery, the controller then backs off the power to keep the batteries cool. This is important for lead acid and AGM batteries. However, lithium iron phosphate batteries don't really heat up as they're being charged, so you don't need a temperature sensor for this type of battery. Also, if your solar array is under 150 watts, a temperature sensor is not that important. The connection sequence is very important when connecting your system. The solar controller is powered by the battery bank, not the solar panels. So what you want to do is first wire in the battery bank first. So connect the battery terminals to the controller. This will start the controller, it'll power the controller, and the meters will come up and begin the display. Then you attach the solar panels to the solar controller with the switch open, and then you close the switch and your system becomes active. If you have a battery monitor on board, such as a Victran monitor shown here, then you would have what's called a shunt. And the shunt is a device that is attached to the negative wire from the battery. And then on the other side of the shunt is all the items putting power into the battery and taking power out. So the shunt is used to measure the current going over the shunt or the bridge. Now, if you have a battery monitor and a shunt, the negative from the controller will go either to your negative bus or to this negative or to the house side of the shunt. This is so that the battery monitor can measure all of the power coming in from solar going to the bank. So in this diagram, this is really a complete solar system, if you will. We have two panels wired in parallel using our MC4T branch with an on-off switch going into the controller, two wires coming out from the controller, the positive going directly to the battery bank and being fused, and the negative going to the house side of the shunt, or, if you will, the negative bus bar. Solar controllers need to be programmed to set their parameters. Now, the key parameters for a solar controller are typically the size of the battery bank, in amp hours, the type of battery, such as lead acid, AGM, sealed, or lithium iron phosphate. And some controllers ask for the setting of the time and date. And that is used primarily for setting the equalization mode if your controller has the capability to equalize the batteries, say, once a month. If you have a special type battery that is not listed as a default set of parameters, then there's often a setting called a user battery type. And the user battery type can set each particular parameter for battery charging. Things like the amount of voltage going in at various charge phases, the maximum cutoff voltage, the minimum voltage, things of this sort. Now, the controller parameters can be set using either the meter that's either built into the controller or the meter that it might be attached to the controller, or a Bluetooth app. Now the Bluetooth app for EP controllers is available on Google Play or Apple Store. Just search for EP Ever. You can download the app. To use that app, you'll need the Bluetooth dongle option, which is a small box that plugs into the solar controller to support Bluetooth. Victron controllers, look for Victron Connect on Google Play or Apple Store, and you could download that and connect to any of the Victron controllers that are in the Smart series. The Smart Solar series of Victron all support Bluetooth also. Also, in programming the controllers primarily for the EP controllers, on our website, we have an item called Quick Tips for Programming Controllers. That's under Support, Manuals and Info on the Custom Marine Products website. And that gives you a step-by-step which buttons to press when to program the controller. Let's talk about troubleshooting. Two of the most common questions that we receive. First is sometimes the meter will show a voltage coming from the solar panel, but 0 amps coming from the solar panel. Why would that be? Well, it's most likely that the controller is not getting power from the battery. So if this happens, the controller will still display voltage. It's getting a little bit of power from the solar panels to display the voltage, but not sufficient power to process the power and charge the battery. So in this case, check the battery connection, and most important, check the fuse to be sure the fuse is in contact and still active, hasn't been blown, and see if that reactivates the controller. If not, measure the voltage of the two battery wires going into the controller and see if the battery is getting power. If it is getting power, you might also look at the on-off switch, and you might start at the controller and work back toward the solar panels, being certain that each MC4 plug is plugged in properly and is making contact. So use the meter to go up and down the cables to find where the power gap may be. It's most likely a problem with the wire between the solar controller and the battery. Now, also another problem that we hear about is the solar panels are not producing the full amount of rated power. Why might that be? Well, there's a number of reasons. First of all, as a panel heats up, its efficiency is reduced. So as a panel heats up in the sun, its power output will actually go down. And a general rule of thumb is for every 20 degrees above 77 Fahrenheit, the panel performance will reduce by 30%. So it's not uncommon to see a solar panel at full sun heating up to around 140 degrees Fahrenheit. So at 140 degrees, its performance will actually be decreased by 10%. So a 100-watt panel, which is rated at 100 watts at 77 degrees Fahrenheit, will actually produce 90 watts once it gets very warm. Also, if the batteries are fully charged, or there's other charging sources active like a shore power controller, the solar controller will either reduce current or even shut off the battery to prevent overcharging. So it's doing its job. So this will be reflected in the meter. So if you're not getting everything from solar, it's because it's backing down, because the batteries are either at full charge or they're being charged from another source. So the controller is doing what it's supposed to do. It's preventing the batteries from overcharging. Finally, there could be a loose or defective connection in the MC4 connectors or the wiring between the solar panels and the solar controller. So as mentioned earlier, start at the controller with your meter, see what the voltage is, and work your way back step by step to each connection, check the voltage, and then finally getting back to the panels and what they're producing, and you'll be able to find that faulty connection. So this is the end of our seminar on how to wire your solar controller system. If you have any questions or comments, feel free to contact me at the contact information shown on this screen. There are additional slides available to you here regarding wiring. So let's while we're at the end of the presentation, let's just move on to wiring for just a minute. The following slides are a number of different wiring diagrams that different customers have used on their boats. These are the most common, typically the most common ones. Vary depending on the number of solar panels you use and the type or number of controllers that you use. So I invite you to browse through the following slides, and perhaps you can find a wiring diagram that is close to the solar array and controller design that you're using on your boat. Thank you for attending and have a wonderful day.